All right. So f of a, I definitely need to know what that is. Because it wants me to figure out what the hell this whole thing is. I'm like, oh shit, I don't even know that. Okay. Well, I do know what f of a is, yes? What's f of a? You guys already told me. Just replace x with a. Is that right? That's all function notation is. So what's f of a plus h? Replace x with a plus h. A plus h, the whole thing, right? Because that's what's in there. So I get a plus h squared minus twice a plus h plus 3. And then I've got some simplification to do, right? The f of a was kick ass. There's no like terms, there's not, it's just a squared minus 2a plus 3. Thank you, f of a. F of a plus h. So I got work to do. What is a plus h squared?
A plus
Good. A squared is 2ah plus h squared. You gotta actually FOIL that back, right? It's not just a squared plus h squared. So it's a squared plus 2ah plus h squared. What do you do here?
minus 2a plus 2.
Okay. So this is what's called the construction approach. You're asked this question that's got all these parts. Figure out each part and then throw it all together. So I'm going to replace this with this. That's going to go there. Minus, this is going to go here. You guys kind of with me? And some stuff cancels. Do you see that? All right, that's enough. I'm not going to do it anymore. You guys can finish it up. I'll tell you this. The h's should cancel. Let me ask you this question. Could you put a 0 in for h right now?
No.
Why not? Say it one more time. Oh, indeterminate. I love it. Not only is the bottom 0, which sucks already, but so is the top, which is even worse. I need you to understand this. What's 3 divided by 0?
Undefined.
Undefined, right? Real quick side note. You guys know why we call it undefined? Why not? Real quick, what's 6 divided by 2? Holy shit. Why? Don't use division in your answer. Why is 6 divided by 2 3? Because 2 times 3 is 6. So 3 is the number defined in such a way that when I multiply by 2, I get 6. That's a long ass way to say that, but let's go with it. So what's 3 divided by 0? It would have to be the number defined in such a way that when I multiply it by 0, I get 3. Is there any number defined that way? No. So it's undefined. Shabam! So it's really good to know why we use a certain word. Because it actually gets to the heart of what's freaky about that thing, which is a good thing to know. In this class, we're going to analyze some of that freakiness a lot more than you ever have. So when it's, does everybody see how this is 0 over 0 if I try to plug a 0 in? What's the top? Is that f of a minus f of a? And that's 0. And the bottom is 0 if I make h 0. So that's 0 over 0. That's going to be very important to us in this class. It's going to mean that we can actually do something to figure it out. So we'll get there. So just to give you a little heads up, if you do this correctly, the h's should cancel. Okay. Yes?
So do you want us to leave the simplified answer or solve for it?
Yeah, just whatever you get. When you cancel the h, you should be done. Because there's nothing else you can do. Okay.
There'll still be variable, right?
Still be variables, yes. You should get something like 2a plus h plus blah, blah, blah. I'm not going to give it away. Yeah.
You just did.
I did. Huh?
How was the top 0 again, real quick?
Oh, if I make h 0, what does this become?
A plus 0.
So f of a minus f of a.
Oh.
Yeah, cool. I like it. Oh, that's my time. No, don't get too excited. Somebody actually goes like, really? No.
Oh.
Joke.
No, it's just sad.
Anything else from homework stuff? Is everybody cool with number 4?
And I can go through the ebook and find the same.
Say again?
Same numbers. I can go through the ebook and find the same numbers.
Should be,
Okay.
yes. As long as you got the correct
Yeah, I got the
version of the ebook.
from the email.
I was thinking number 5. I need the domain, but I didn't know the domain.
Okay. Did you have a question about the one we just did, or?
No, that's a different problem.
Alright, let's look at number 5, and then I'll come to you, Brandon. Oh yeah, that's right, frozen. 5. So just so the person knows, I'm not talking about just them, but I often get students who just give me the answers for these problems. I have a shirt that I'm gonna wear, I should have worn it today, it says show your work, that's all it says, right? I mean, that's the thing, I need your work, otherwise I can't do anything for you. I have no idea what you're thinking about wrong, if you got the wrong answer, I gotta assume the worst. If you just give me the answers for these, that's not good enough, you gotta explain it, and don't just say, I graphed it and I saw, no. There's no little graphing calculator, so this is not a problem you should do in your graphing calculator. You have to do this problem. You can't just delegate it to your calculator. So how the freaking hell, in number 5, what piece of it did you have trouble? Right, so let me start with domain. How would you get the domain of number 5? What is domain, by the way? What is domain?
Domain is the x-axis.
All the x's that have outputs. All the x's that work, correct? Why could there be an x here that wouldn't work?
That's a 0 on the bottom.
If the bottom's 0, this thing goes to hell. So then how do you figure out what x value is no good? You take the bottom and you set it equal to frickin' 0. So if you can say in English what the problem with the function is, translate that to Mathish, because Math is a different language. The bottom can't be 0. Oh, 3x minus 1 can't be 0. Solve for x. That's the work I need to see. If you just give me the answer, I'm going to go, why? And then you're going to correct the top of your paper.
Well, I thought there was range.
All right, now let's talk about the range. I want to make sure everybody's looking at this the right way. Does anyone know what that would look like if you did graph it? Does anyone know what would happen? By the way, can you guys all see what x value freaks this thing out? 1/3. If you try to plug a 1/3 in, things get freaky. Yes? What happens at 1/3 though? That's the location of a what? Not a hole.
Horizontal.
Vertical asymptote. Vertical asymptotes. I always think about Star Wars because it's a drop, pull up, this shield, so you can't go across the damn thing or you'll die. So it's a literal wall you set up and your function's gotta like, oh shit, oh crap, you can't. So it's gonna look like this, yes? There's gonna be a wall at 1/3, right? There's also, inherently in the way I'm doing this, isn't there another wall this way? Horizontal asymptote. Horizontal asymptote eliminates a y value possibly, right? So if you figure out where the horizontal asymptote is for this, you'll know what to throw out of your range. Do you guys remember how to figure out, there's 3 situations for a horizontal asymptote. Do you guys remember them? It's got something to do with the degrees of the top and the bottom. Yes, something related to the leading coefficient. All right, let me erase the board before I forget, so you guys don't freak. I'm already somewhere else. Okay. You gotta remind me. I'm sorry. I don't like the overhead, but it doesn't make sense not to use it. So, too bad for Jeff. Okay. All right, get out of here. Okay. Oh my God, I was zooming in and out. Alright, so if I have this, is the top or bottom growing faster when I let x get really big? Bottom's growing a lot faster. So like 1/2, 2/20, 3/200, aren't the bottom and top both growing? 1, 2, 3, 220, 200, but the bottom's growing a lot faster. Isn't the division going to 0? 1 divided by 2 is 0.5. 2 divided by 20 is 0.1. 3 divided by 200 is 0.06. Blah, 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 0.0, that's wrong, Jeff. 0.015, there it is. Blah, 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 blah. So as I keep going, all the outputs get smaller and smaller because I'm dividing by something that's growing much faster than my top is. So what is the horizontal asymptote here? Y equals 0. It's approaching 0, yes? Okay, does this sound familiar? So when the top degree is smaller than the bottom's growing so fast, it makes the outputs go to 0 when I let x get big. When x gets really big, the bottom is stupid big, the whole thing is basically getting stupid small. Another name for stupid small is 0. To write it in a different format. If I let x go to infinity, what's the limit as I let the input go to infinity? 0. Who's got a calculator? Okay, put f of 1,000, put a 1,000 in there. So 1,000 minus 3 divided by 1,000 squared plus 4. Whatever the shit that is. 0.0000997. I think it was 0.0000993. It's a guess. Does everybody understand what I'm doing? I'm putting a really big number in. You're really careful, you put this in, you gotta put parentheses around, yes? Okay, let me do it. Let me see.
I got
What you got?
9.9699601.
What's at the end? E?
E to the negative 4.
Negative 4. So that means times 10 to the negative 4. So that's 0.1239969. Would you agree that's pretty small?
Mm-hmm.
If I put a million in there, it's going to get even smaller. Because now I'm dividing by some. A million squared plus 4 is way bigger than a million minus 3, yeah?
Stupid small.
Stupid small. Poor little dude, yes.
So just to reiterate back to what you were saying, as x grows, everything the rest gets smaller.
The bottom is growing so fast. I'm dividing by a number that's getting so big, and the top can't keep up. So the limit's going to be 0. There's going to be an asymptote at 0.
Right. Okay.
So look, yes.
Do you want us, like when we're showing our work, do you want us to just say like little 1 or something?
No. What I really, for example, if this was the problem, he'd say the top degree is lower than the bottom, therefore there's an asymptote at 0, so therefore the range does not include 0. Is that, you could say all that business. Yeah. You guys all right? Does this seem familiar? Does it make sense?
And then, if
Okay.
the top degree is higher than the bottom, then that would be,
Yeah, it would go to infinity. All right, so let's talk about this just for a moment longer. If I have 1 over x, what's the bottom degree? 1. What's the top degree?
0.
Beautiful. A degree is how many variables I see. I see 1 variable on the bottom and 0 up top. What is x to the 0? 1. Okay, so what's on top? X to the 0. 0 degree. Is the top degree smaller than the bottom? Hell yeah, 0 to 1. Yeah. If I put big ass numbers in here, isn't that 1 divided by big ass number? 1 divided by BAN? So as I let that number get bigger, without bound, I just let it get as big as it wants to, what are the outputs going to do?
We're gonna get small.
Get insanely small. So if I let the number just keep going, the outputs will approach 0. Will they ever get to 0?
No.
Good. What's the only way a fraction can equal 0?
0's on the top.
If 0's on the top, and what is on the top of every one of these?
1.
1. Every time I put a number in, isn't there a 1 up top? But what is 1 over 18 trillion? For most humans, that's basically 0, right? So if I let the input get really, really big, this whole thing gets really, really small. It's gonna go towards 0. Okay, so that's why the picture looks like this. Whoa, that's a little extreme, Jeff. So there's an asymptote at 0. So what's the range of this? The range of this is negative infinity to 0, 0 to infinity, right? You can do it, Jeff. Put a little U in the middle for union. Does that look familiar? Even though am I chicken scratch? Okay. Yes?
So find foods like other notations, like why such that, why.
Oh, sure. Interval notation is the most concise way to say it, but you could do stuff like, even if you just do this, but this would require y element of the reals where y not equal to 0, that's not, you could just say it like that. You could say it like y less than 0 or y greater than 0. That is acceptable, but just intervalization, just visually the best way to kind of like give it. Okay, I like it. Now again, if it's been forever since you took pre-calc, in the title of that class, it says, oh shit, this is the class you take to get ready for calc. So you're gonna have some review to do, yes? So unfortunately, that just means you're gonna have a little more work than normal, but you know, you're motivated to do that, so you don't have to try to take pre-calc all over again. Okay. Now very quickly, just so you guys understand, if I had this,
Ratio.
It's gonna be a stupid small.
no.
Oh, wait.
It's gonna be the same because it's the same degree.
So as x gets big, the top and the bottom both kind of grow at the same rate. Do you agree?
Yeah.
So neither one overwhelms the other. In the first example, when the bottom degree is higher, the bottom is overwhelming the top. I'm dividing by something, getting stupid. So of course I'm getting smaller, smaller, smaller forever. And what's the smallest positive I could be is just above 0, right? This problem, watch this. Okay. I can't remember, remind me if I did. Have I used this notation with you yet? Besides what I did up here?
No.
I thought I snuck it in somewhere.
Well, yeah.
If I let the inputs go to get really big, what happens to the outputs? That's basically what that means. So if I let the inputs get really big, just stay with me for a second. Oh, what time is it? Okay. We're gonna take a little field trip in a bit. If I'm letting the inputs get really big, are they close to 0? No, they're getting really big, very far away from 0, correct? Okay, here's the long ass way to do this. Here's the long way to do this. If x is not 0, am I allowed to divide top and bottom by x squared? Of course I am. I can divide by whatever the shit I want to, top and bottom of a fraction, as long as it isn't 0. And you just told me we're nowhere near 0, so I can do that. Now you're like, you might be sitting there like, you can, why do you want to, Jeff? Well, here's why. If I divide each piece by x squared, what's this? X squared divided by x squared is 1. 5x divided by x squared is 5 over x. 1 divided by x squared is 1 divided by x squared. That's crazy. Sound like an auctioneer then. 1 divided by x squared. 3x squared divided by x squared. That's crazy. Minus 2x over x squared. I lose an x, right? Plus 4 divided by x squared. All right, let me stop for a minute. Does that look better? No, but it actually does. That looks so much worse than this until you realize each one of these, when x gets really big, what does that piece do?
Go to 0.
Goes to 0, yes? When x gets really big, that goes to 0 even faster. That goes to 0. That goes to 0. So what's the only thing left?
1/3.
So the answer is 1/3. So why do all that shit when the same thing would happen? If the degrees are the same, you can just look at the ratio of the leading coefficients. That's it. Why does that work? Because if you did the long ass way, that's what would be left. So why do the long ass way? Just make a shortcut out
Because
of
you're
it.
supposed to show your work.
Oh,
Yeah, and we did. All right. Now, Mike, if you want to, you can show your work every time. But a big part of mathematics is showing the work once and then making a shortcut out of it.
Oh,
So in pre-calculus, hopefully your instructor showed you this, like I showed you guys. Showed you why this kind of works. Yes?
I've been taught by my high school professors that shortcuts work at some points. Is that true, or are they?
Certain shortcuts suck.
Okay.
That's why I make it very clear which shortcuts I let you use, because they're the ones that actually work all the time. Yeah.
Makes sense.
Students, if you try to make a shortcut yourself, you want to verify that shit. Because it could be a very specific situation where your shortcut works.
Right.
Okay. Let's go. Very good.
Okay, so for the range, you're finding horizontal axioms, basically?
Yes, because that is the one output that I might have to throw out. Because there's kind of like a wall there.
Well, like, for example, like the ln x plus 6 and number 7.
Yeah, they don't all work that way. The first one is a rational function, so it's got a way for it to work. Let me see, what was the...
So
This one?
Yeah, for number
Okay.
6. Or original.
Number 6?
Yeah, that was fine.
Alright. Six, okay. Oh, this one's so cool. Alright, guys. You're in calculus. You got to start stepping out of the math, right? Range. What is range? What is the range? All of the outputs. And in fact, for a lot of functions, a lot of like regular functions we look at, they're kind of nice. So it's really just what's the lowest output, what's the highest output. So can somebody tell me, this is a square root. What's the smallest output a square root can have in general? 0. Because can a square root equal a negative number? That's the idea of a square root, right? It can't be negative. How do I get a 0 out? What would I put in? 2, yeah. That would be related to the domain, but we're talking about just the range. The lowest any square root can be is 0 if I can figure out an input that would make it happen. So if I put 2 and I get 0, okay, 0 is the lowest. What is the highest output? So how can I make the inside number the biggest it could be? Nope. Because I want you to really think about this. Aren't I subtracting a positive number for almost any input of x? Do you guys see that? Do you guys agree x to the 4th is positive? Because we're talking about real numbers, yes? Unless you want to start doing calculus complex, I'm open to it. Okay, shit. I always try. I really want you with me. The inside says it's 16 minus something. So what's the absolute biggest that could be? 16. If I choose to subtract 0, and I can make x 0, correct? So do you understand? This is less mathematical. You don't actually have to like do work and add the 16 and take it. No. Okay, what makes it smallest? Okay, smallest is square root is 0, and I can make a 0. Okay, 0 is the smallest. And what's the biggest? Okay, let me subtract the least from 16. Oh, if I make x 0, that's okay. What's the square root of 16? All right, so there's a gimme. The range for number 6, 0 to 4. And how did we get that? Just by looking at the damn function, right? So students, I don't blame you. I don't blame you because especially when you come out of pre-calc. Pre-calculus is dense in topics. So a lot of stuff happening in pre-calc. So you have no time to like sit with the problem. You're like, I got your problem. What's the next one? Okay. You have no time to like, let me think about this. Let me look at. No, you have no time. Here it's going to be a little more spread out. The first day was a little insane because we were reviewing a lot of shit. But we're going to kind of slow down now. Sit with the problem. Just say, what is this? What's going on with this thing? Yeah.
Sorry, this is a question. If x were 4, 4 to 4 is greater than 16.
Totally. So now that's how you start thinking about the domain. What's the biggest input I can do? What's the smallest input I can do so the inside stays real? I'm sorry. So the inside stays non-negative, so I stay real. Yeah. So you were already thinking about how to get to the domain with less math work. Does it make sense? What would I make x so that it doesn't become negative, right? And you basically already said the answer earlier. Yeah.
Going back to where you were saying x is 16 and all that, but if you're, you have that mindset sometimes of what is that, what can x be? Saying over the 2 to the 4, that is 16, making it 16 minus 16, that equals 0.
Totally. Which is cool, right? What's the square root of 0?
0.
Beautiful. And isn't that the smallest I could possibly get out of it?
Yes.
Could x be any bigger than 2, like somebody was just pointing out? What would happen if I try to make x any bigger than 2?
It would go negative.
So the domain, what's the highest thing in the domain then?
2.
Freaking 2. So we already got half the domain figured out. If you just think about it, you should know how far you can go the other way.
So basically, just, I mean, granted, I know it's basically cut the answer out overall, but you want to find the domain and range. And it said, put it in notation, the notation would be 0 to 2, or 0.
For the range was 0 to 4.
Yeah.
Yeah. The domain, we got half of it is 2. You got to think the other way now. What's the smallest x I can plug in that would still make it work? Nope. If I plug it,
Oh, you could
Negative
plug
numbers.
in any.
-2.
Yeah.
If something weird happens at 2, the same thing happens at -2 because I'm raising it to the 4th power, so they both have the same output, correct?
But it,
If I raise something to the 4th power, if it's positive or negative, it comes out the same, yes? 2 to the 4th is?
That's
16. What's -2 to the 4th? 16. So the exact same thing happens both ways. So if you're paying attention, you just got the domain answer on that shit. Yes?
How do we know that we couldn't put in a bigger value to get a negative and couldn't solve for a
Whenever they're talking about the domain range, unless they specify it, they are talking about across the real numbers. If I want to bring complex numbers, the problem has to say across the complex numbers. So that's how I know I can't let the inside become negative. Because that crosses into complex and we're not allowing that. Again, unless you want to.
no.
Ooh, okay. No? Okay, shit. Damn it. Alright. That's a good answer though, kids. Always answer no if you're given the choice. Trust me. Anything else? One more question maybe? And then we gotta get going. Yes.
For number 4, what I did, I just drew like.
Oh yeah, I was wondering about number 4.
Yeah, that one.
Was it already there? It was already there, Jeff.
So the other-
So if you don't put any fertilizer, you don't have to suddenly become like an agricultural expert. You don't have to go take like, get a degree in agriculture, come back and answer number 4. Just what do you think is gonna happen if you put no fertilizer at all?
That's still
You
Nothing.
get something maybe, because maybe there's something. So when you make your graph, you're not gonna start at 0, 0. You're gonna start a little bit above there, yeah? And you don't have to make a scale, it's just purely visual. You don't have to make a scale, you don't have to go research, right? Put a tomato plant into, it didn't even tell me what kind of thing.
Would it be like,
Did it? No.
would it be like this or like this?
Now listen, start to put a little fertilizer on, what should happen now?
Okay.
Give us some time, you should get, now, at some point, can you imagine, start dumping that literal shit on there, right? Just start dumping the shit, just dump it and dump it. What's gonna happen eventually?
Nothing.
What's gonna happen eventually?
It's gonna burn out.
Is it gonna get any sun? Is it gonna be able to work its way through all that shit? No. At some point, your yield's gonna go down again. Damn it, Jeff. So if you're paying attention, I should give you another answer. Yes. No. No. Well, maybe.
That's what I got.
Yeah, beautiful. I love it. Ooh, you got it all detailed, but you don't need. But that's
Yeah. We got 1 acre of Maui Wowie under cultivation,
Oh, this one.
got 8 rows.
Oh, man.
You know,
that's some dang stuff. All right.
bushels of dope,
Oh, dope.
kilograms
All right.
of ammonium nitrate.
Got you.
Okay.
All right. So let's get back into where we left off. So we're about to get back into chapter 2. The way I like to do chapter 2, just to let you know, I'm going to do 2, 2, 2, 3, and then I'm going to go back and do 2, 1. 2, 1 is insanely technical. So I kind of like to do 2, 2, 2, 3, which is a little more free-flowing, get the idea down, and then I like to go back to 2, 1 and get the real like technical nitty-gritty stuff. So even if you don't want me to do it that way, I'm going to do it that way. We sort of got into limits the tiniest bit last time, but let me give us a visual to work with. Thankfully, I have a handout here in a bit, so you don't have to worry about my graphing ability. So I'm going to put some points here. So I got a closed circle and an open circle. And I'm going to put an open circle right there. I feel like Bob Ross in that position. A little open circle is, right? And then I'm going to do
Happy circle.
a happy little circle. I'm going to do this thing. Okay, so we got that. So I got an open circle at 2, 2, open circle at -2, 1, and a closed circle at -2, -1. That's what that's trying to be. It went way down there for some reason. Okay. So, right there, does the function have an issue here?
Yes.
Okay. Do you guys remember, we did talk about limits a little bit. The whole thing about the blob and all that stuff. what is the main thing a limit does for us? If there's a place where something freaky happens, you all agree something freaky happens at 2, an input of 2, yes?
Yes.
So what's a limit let me do? Do I ever get to 2 then?
No.
So the idea, if I said the limit as x goes to 2, we don't ever get to 2. If we did, we'd fall in the damn hole. You don't know where the hell we're going to come out. Okay, white hole, different universe, freaky shit. Circles that have corners, you know. So if I want to know the limit, I'll call this f of x, just to be totally original. The limit as x goes to 2 of the function. Now, if I ask you, what is f of 2? Let me just ask you this. This is a separate question, right? This is A, this is B. If I say, what is f of 2? What is your answer? Undefined. Because f of 2 says, when you plug a 2 in, what do you get out? So when I say f of something, that is looking just at that point. So freaky shit, it's undefined. Right? You guys with me? The limit is kind of the opposite of that. It says, I'm going to get close, but I'm never going to freaking get there. So now your question is, all right, you said it a few times, what the shit does that mean? How do I actually do that? I don't know. Oh yeah. So this is undefined. So let's say this is a road. I'm traveling on this road. Can you imagine us? There's a little car. Here I am. Traveling on this road. So as and see right here, there's an input here. Do you guys agree? It's like 0.7 maybe from where my car is. So I'm going to kind of like, my car is on the function, but I'm looking here to see where I am. And I'm going to let the location go to 2, but I never get there. So as I come to this point, as I come to the input of 2 from that side, what does it look like the outputs are going towards? 2. Yeah, as I let my inputs approach 2, my outputs are approaching 2. You guys agree?
But it never touches it, right? That's the limit.
That's the limit. It never gets to 2. This is all about what does it look like it's doing. You guys got it with it? Yeah, okay. And what about on the other side? What about another person, and they're going to have a much more exciting time on this side? Look at that shit. But as they approach that pothole, what are the outputs? So now I'm here. As these inputs approach 2, what are the outputs approaching? Also 2. So if I say, what is the limit as x goes to 2, does this question say what side it's coming from?
No.
So it must be true about both sides, because it doesn't say which side. So here the answer is 2, because the outputs look like they're going closer and closer to 2 as my car gets closer and closer to that puddle. Let me stop for a minute. So the question f of 2 is what's happening right at 2. Limit as x goes to 2 is what does it look like it's going to happen? The limit doesn't even know there's a hole there. It's just like, it looks like it's going to 2. And f of 2 is like, oh shit, the road's gone. Okay, maybe. If the function can talk, that's what it would say. So let me ask you this question then. I'm just going to write this. Tell me what you think this means. So far this makes sense, yes? I'm letting my inputs go to
minus 2.
-2. Let me put one more little symbol there. From the left. So now put a little car from the, I want to approach -2 from the left. So I got my little car here, yes? My little weird ass buggy. So right here I'm at an input of like -3, you guys with me? So now I'm going to say, okay, my little car moved forward, so the input is -2.5. So now I'm like here, yes? What does it look like the outputs are doing as I approach just from that side? Looks like they're approaching 1, yes? Do I make it? Nope. But the limit has no idea what's happening there. It just says, what's it look like it's going to do? So as I approach, I really want everybody with me. I just introduced new notation here. If I put a little negative sign, that means only consider it from the left. So as I approach this from the left, the outputs seem to be approaching 1. They don't get there, the limit don't care, right? And of course, what's the next question I'm gonna ask you? What do you think we're gonna put there now?
On the right.
So what symbol am I gonna put there?
Plus.
Holy shit. That's what we should have done. No, I'm joking, that's what we did, okay. And what's that limit? It's not 1, is it?
Negative.
It's not 1. If I approach from the other side now, right?
Negative.
So now I'm approaching from this side, my car is approaching
Does not exist.
negative 1. Why?
I was thinking because the point's not there, but it doesn't know it's not there.
Oh, this point's actually here, isn't it?
Yeah, that's why I was thinking it wouldn't be negative once it's not a limit, it's a point on the graph.
Oh, I see what you mean. The limit has no idea what is happening at that input that it's approaching. It could be open, it could be closed, it can go to infinity, it can do all kinds of weird shit. It has no idea, it just cares what's it look like it's doing. So it's closed, open, doesn't change the limit. If I would have made the top one closed and the bottom one open, my 2 answers would be the same. That looks like it's going to 1, this one looks like it's going to negative. So let me ask you this question. And you're like, yeah, that's what you're doing, man. Okay. What is the limit as x goes to negative 2? Period.
Define.
I appreciate that.
Oh, that's just the answer, sorry. Because there's 2 outputs for the same input, then it shouldn't be defined, right?
Yeah, the limits don't agree. Correct? Therefore, there's no answer for what that is. So here's what we say. We don't say undefined because that's reserved for functional outputs. And this is not a functional question. This is just, what does it look like it's going to?
Oh, D
Does not
and E.
exist.
Does not exist.
DME.
Does not exist. DNE. It's okay. No, I appreciate, normally I'm the
It's
one that
like,
goes
wait.
screaming.
And a brain left.
Yes.
We had,
DNA.
-1 for the SX.
For this guy? Oh, so again, if I approach from the right, so I'm approaching from this direction. So then I let my car be here, and I let my car be here, and I let my car be here. What's it look like the outputs are going to? 1, yeah. Okay. And please forgive my poor scale on my thing. Yes.
So the input and the output are like particularly matched with what direction we're going into?
No, careful. The limit could be different based on what direction you're coming from. Let me ask you this question then. What is f of negative 2?
-1.
Negative 1. Is there an output at negative 2? Yep. Could it be 1? No, it's a freaking open circle. So, but there is an output at negative 2, correct? And that output is negative 1. Yes.
So right now, we're just kind of guesstimating because we can obviously see that that's -2, -1. But how are we going to find the limit for a point on a graph that isn't graph?
Some problems might say estimate, so you just have to kind of eyeball it.
Okay.
Most of the problems they're going to have you do are going to have definitive points, right? Like whole number answers, you know what I mean? Otherwise, it's kind of like, is that 0.7 or 0.6? Is that what you're kind of talking about?
Yeah.
So there is one question, I think, where they ask you to estimate because it's not quite perfect, but then you can say 0.5, 0.4, whatever the hell. If it's 0.4 and you say 7.8, that's a problem, but you know what I mean? I'll accept a few different answers when you have to estimate it. Yeah.
When we were looking at the limit when x approaches -2, from the right, when we're looking at it, if it's approaching from the right.
Yes.
What is after the point there was still a line that was like going downhill?
Oh, you mean after here like this?
Yeah.
So instead of up here, it was down here?
Yeah, but like, would that affect the limit?
No, because again, if I'm going from above, not only do I have no idea what's happening right at the point, I definitely have no idea what's happening after that. This limit, the limit as x goes to -2 from the plus, from above, only has any idea what it looks like it's doing as I go this way. Has no idea what's happening at this point. It definitely has no idea what's happening afterwards. So if I put that here, the last answer wouldn't change. I like it. Okay, maybe. And again, how much have you worked with this idea? Not much, okay. So let it start to sink in. This is definitely not like something you're born with. Of course, they spanked me and I knew all about limits. What are you talking about? Real quick, this is so marked up. Let me do this again. So if I have this, right? What's the limit as x goes to 3? So, does not exist is actually technically the right answer, but you can be more specific. Does it not exist in a specific direction? It goes to which infinity, positive or negative? Obviously, positive. So this answer, I want it to be positive infinity. If you say it does not exist, you're technically right, but you can be a little more specific. It's got a specific way it doesn't exist. It goes to infinity. You guys kind of
Yeah, it also never reaches 3, right? Never touches that point?
Yeah, and the limit has no idea.
Oh, okay.
All it knows is I'm trying to get somewhere, my little car just keeps going, and I'm like, okay.
Oh, it keeps going up.
I'm sorry. So, yeah. So what do you think about if
How
I
would we
have?
write the answer?
Sorry?
How would we write the answer since you're saying it doesn't exist, but also it's also
Positive infinity. I would highly recommend you put the plus sign, because you might have a mark that looks like a negative. So if you make it plus for sure, I'm like, okay. What if I had this going on over here? Let's say this is 8, just to say. What's the limit as x goes to 8?
Negative infinity.
Careful.
positive and negative.
Does not exist.
What did we just say when they don't agree?
Does not exist.
Does not exist. So when they don't agree at all, I can just say does not exist. If they agree, but there's really no number they go to, that does not exist, but specifically positive infinity or negative infinity, right? Okay. Yes?
Why like when x go to 8, it does not exist?
Does not exist, yes.
Why it does not exist?
Because this side, if I do it from above, it's going to positive infinity. If I do it from the left, it's going to negative infinity. Do they agree? Anytime the limits don't agree from one side to the other, I don't care in what way, anytime they don't agree, it does not exist. So if I said, if we're going to a pothole somewhere, if we both do this, didn't we agree on our end destination? Couldn't we then say our destination was that pothole? If it's at 3, that's our limit. If you went to this pothole and I went to that pothole, did we go to the same damn pothole? So did we have a single destination that we both went to? No, we didn't agree. So what was it? It doesn't exist.
Like a speed limit. You only have one speed limit. Everybody has to know that there's only the one speed limit.
Oh, is that true? Oh,
There's
shit.
speed limits on the same road.
That's right. I always have my own personal speed. I'm with you. I got you. Okay. So when I give you a visual, you want to see, and by the way, this is just 8. If it doesn't have a plus or a minus, that means you must think of both directions. If they don't go to the same place, that's actually nice. You just got a quick answer. It does not exist. Yeah.
So like, if it was like the question on the homework, and it was like, I use the limit at like 8, would you just write do not exist, or would you actually like go individually do the plus and minus?
No, you could just say does not exist.
Okay.
Yeah. I appreciate if I gotta work this, I gotta show this to show your work, and I say show your work, and you're like, oh, good Lord, I better show this guy some work. That would be great if you say it doesn't exist because they go to different locations. But if you just say don't exist, I'm cool with that. There shouldn't be too much work on these kind of problems. Yeah. Okay. So let's get a little more technical. A little more technical, which should not be unexpected in a freaking calculus class. We're getting a little more technical. What if I want to investigate the limit as x goes to, what do you got, Jeff? It doesn't matter. Let's do 3 of, yeah, we'll just do this nice and easy. Yeah, I like it. Okay. Now I'm going to do this the long way, and I made it easy on purpose. I'm sure you guys can see something I can do with this, but I'm not going to do it. You're going to get more disgusting functions in here. You're going to do the same thing I'm about to do. So to investigate this, and again, somebody help me out. Remind me, what the hell does this want me to do?
It wants you to figure out.
It wants me to get my inputs.
Like,
Close 3
really close to 3. So let me literally do that. Let me plug a 2.5 in. Is that close? Can I get closer? Okay, so let me plug a 2.5. I'm going to make a little table of values. Plug a 2.5 in. How do I get 2.9? Is that pretty close?
Yeah.
All right, what about 2.99? Now, so far, I'm investigating the limit as x equals to 3 with a little negative sign, correct? Because I'm coming at it from the left.
Don't you also have to do like a 3.0?
It's like I planted you there. I love it. Exactly. I better go from the other direction. So let me show you guys something. I forgot to bring my little cooler of calculators, but let me just show you this. See how many of you guys know you can do this. Because we're not in freaking math 88, I'm not going to make you freaking do each one. Watch what you can do. Look what you can do. You can wait for your calculator, remember to turn on. There we go. Go to y equals. If you have a calculator, go to y equals and plug in the function x squared minus 9 divided by x minus 3. Notice I'm helping the poor calculator out. It's got no eyeballs. Maybe the TI 1000 is going to have eyeballs, and then Skynet. Yeah.
Do you remember how to reset not reset it, but refine the Y value?
Oh. Hit mode. And you see down there it says func, and it says par, and it says polar.
Yes, sir.
Hit make func. Give me that func. Okay. That means function. Now it should be back to Y, yes?
Yes.
Okay. And then clear out anything that's in there. Is everybody with me that wants to be playing along with me? Everybody good? And technology is great. So many errors can happen. I'm not going to graph it. I'm going to go to table. Let me see how I have my table set. Okay. So currently my table looks like that. But I want to be able to tell it specific values, correct? How many of you guys have ever looked at the table before in your calculator? Anybody? A few of you guys, okay. You guys that have had me, you better say yes. Okay. So if I go right up here, see where it says table set? If I hit second window, I can set stuff about my table. Screw this shit. Go to independent. What's the independent variable? That's the input. Because the dependent variable depends on what I pick for the input. So I'm going to make my independent variable ask. So the calculator is not going to do shit until I tell it what to do. Okay. So go back to the table, second graph to go to table, and now it's blank. And you're all like, thanks, Jeff, what the hell? But now I can put in there 2.5, 2.9, 2.99, 3.01, 3.1, 3.5. See, I can put exactly what I want. Now, the most fundamental thing about mathematics is finding patterns. This is all about finding a pattern. Can you guys see if I do this, I'm approaching 3? Yes? What are my outputs approaching? Yeah, you can see it's approaching 6. Yeah, that's cool. Will it always be that? Well, you might have to go to like 2.999 for some functions. It depends on how weird they are. But this one's pretty easy. Can you guys all see that you all agree that it looks like it's going to 6? Kick ass. Will there be problems just like that one in the homework? Yeah. Okay. By the way, coming back to this, can you do any algebra with this thing? So we just determined this looks like 6, but that's that's by sight. That's by. It could be 5.9999999999993. I don't know. 6 seemed to be a good guess. Yes. Can I do any algebra to this? And I should have said this earlier, but do you guys see why I can't just plug a 3 in here? If I plug in 3 in here, what do I get?
You get the indeterminate.
0 over 0, which is worse than undefined. It's indeterminate. And that's one of my favorite words, because all that means is you cannot determine the answer in the form it's in. Maybe I can do some shit to it, and then I can determine the answer. So what did we just do? We did this. That's a legal thing, yes? That's legal. It's completely legal. The only time I cannot cancel these is if x is 3. Is x ever 3? Okay, sweet. And then can I plug a 3 in now? And what do I get? I get frickin' 6, of course I do. We felt pretty good about that being 6, right? So I've got the literally step towards 3, and then I've got the algebraic way, and they both agree. Thanks to gods. Okay. Maybe, yes?
How do we determine if it can't simplify, like we can't simplify?
Sometimes it'll be really in your face. There's a problem on here that we won't be able to. So we can only use a table. I wanted one we could do it both ways, just to show you can get it algebraically. Like if I made the top sine x minus something over, can you factor that? Nope. So you pretty much can only use the table. Later this semester, after we learn some more calculus, we can come back and we have a whole other way to do limits. But that's once we learn calculus. We can't learn calculus until we understand limits, so it's sort of like this paradox. Yeah.
I like good old Jeff.
Huh?
I like good old Jeff, I know what you're talking about.
Oh, okay, alright. Brandon's seen some shit. He knows what's gonna happen. Okay. Okay. So last little thing, and then I've got this handout where I can finally shut up and let you guys try some stuff out. I want to talk about. Yeah. Okay. I'm gonna do. Yeah, that's right. I won't do this whole. What time is it? Oh shit. Okay. All right. I'm late. Damn it. Sorry. I get so into stuff. What we're about to do right now is I need you